Okay. So now, before we finalize everything, I would like to show you the summary of all the equations. So, so we talk about 4 different geometries: flat plate, cylinder, sphere, tube banks, and porous medium. Okay, these are actually 5 different geometries. So how do you use? There is a summary at the end of chapter 7 in your textbook. It's very useful to go around this to quickly identify what equation to use. So first you determine the geometry. Do you have a flat plate? If you have a flat plate, then what are you interested in finding? So are you interested in finding local H, average H, or are you interested in finding the thickness of the boundary layer? Are you interested in finding uh, the drag coefficient for the system? So these are the variables that we can estimate. So to be able to do that, we need to first determine if it is laminar flow or turbulent. Okay. So first identify the geometry. This is number 1. Number 2, if you calculate the Reynolds number and decide if you have a laminar or turbulent flow. If you have a laminar flow, and if you are interested in finding hydrodynamical parameters, we have these 2 equations that's going to allow us that's going to tell us the thickness of the boundary layer delta and the local coefficient of friction. And if you are interested in, there is local versus average. If you are interested in average properties, so the average properties can be found from this equation. So this is local friction coefficient, local friction coefficient, and this is average coefficient. And also important, what temperature do you need to evaluate the properties? So here TF, T film. So this is T surface plus T infinity over 2. This is important. Okay. All of these equations are evaluated at T film, T film, and the validity are shown in here. So the most important equations to remember here is this is the most important one. So this is average Nusselt number. It's going to allow us to calculate the average H for a flat plate for a laminar flow. And if you have a flat plate and turbulent flow, and if you want to calculate an average, so this is the average that you can use. Okay. So in this case, it considers the effect of laminar plus turbulent. And if you only have the turbulent, you can ignore this term. So then you will have only the product of these 2 to calculate the turbulent effect of turbulence on convectivity transfer. So if you start with laminar and transition into turbulent, you use this form. But if you have purely turbulent flow, you can remove H71. Okay. And again, everything is evaluated at T film. So if you have a cylinder, so we actually have 3 different equations that we can use, and 2 of those equations rely on T film, okay, and 1 equation rely on T infinity and Ts. So again, both of these equations will need to use a table. So for table 7.2 for reading C and M, and table 7.4 for reading C, M, and N. Okay, so these are only thing you are free to choose any of these. Just make sure that the validity range is valid for your system. Okay, and this equation here doesn't have any. It doesn't require any table, but it's more complicated. You can use this if you like. If you are using a calculator to program, so this may be easier to program because it will not read an input from. It will not need an input from the table. And then we have a sphere. For a sphere, we have this equation, and everything is evaluated at T infinity. Okay, except mu s is evaluated at T surface. Okay, and this is another empirical equation. This is an exception. So I want to put a star here when you are using T infinity. Star here and star here. So out of all equations so far, only 2 of them relies on T infinity. So if you have a tube bank, so you use T average or T mean. So we have T in, T out. So we calculate the T average, that is inlet temperature of the fluid plus outlet temperature over 2. or for a packed bed, we have this correlation. And again, in this case, we'll be using average temperature inlet and outlet. Okay, so these are all of the equations that are available to you. Ultimately, this chapter is going to allow you to find H bar. It's going to be allow you to find H bar. Afterwards, you'll be using your knowledge in chapter 1 through 5, and then solve a problem. Okay, so you'll find H bar. From H bar, you'll use this information for heat transfer analysis. So you can be using lump capacitance method, resistance method, fins. There will be a lot of possibilities.